Welcome to Half Day Java 8 Streams and Method References Code Camp. Today we are going to cover Java 8 Streams and Java 8 Method References. So let's move on to Java 8 Streams. We are going to talk about what is and why you want to use streams. We'll talk about the concept of intermediate and terminal operations, and we'll talk about the concept of laziness, and then we will see how we can perform stream operations in parallel fashion. What is and why streams? Stream is considered as a wrapper around data sources. Data sources could be arrays or lists that maintain or store data. Stream itself does not store data. Stream basically carries values from the data source through a pipeline of operations. So stream, you can think of operations performing some kind of computation through the pipeline of this operation. It supports many convenient and high-performance operations and expresses succinctly with Lambda expressions, and we are going to see many examples of this in the following slide. For example, like a filter operation will receive a Lambda operation that take the predicate Lambda expression, and that is an example. All stream operations take Lambda expressions as arguments, and operations can be executed in sequence, which is the default, or in parallel. And of course, if you perform these operations in parallel, if you happen to have a multi-core architecture on your hardware, it will result in better performance. And of course, this is useful when you have very large number of items to process. It supports laziness. We'll talk about the concept of laziness in a bit more detail later on. Basically, operations are postponed until how much data is eventually needed. And again, if you don't understand what I'm talking about on this particular slide, don't worry about it. We'll actually talk about laziness using example later on. Now, the reason that streams is extremely useful is because the current technology of collection is not really adequate for processing a large number of data. Issue number one of collection: you have to be responsible for providing loop, for loop or while loop in order to get the answer you want. Basically, you have to specify how it needs to be done instead of what needs to be done. So what needs to be done, if you can specify just what needs to be done and let the system to handle the operation, that's going to be a lot better choice, right? So that is what stream provides. Okay, so a couple of examples. You have a list of customers, and you want to find out who spent the most during the month of May among these customers. And if you have to use a for loop or while loop, you have to actually have several of those, and that is a bit inconvenient. And another example is you want to compute average age of those customers. Again, you have to use a for loop and while loop. You have to add them up and then divide by number of customers and things like that. Issue number two: it's very difficult to write parallelizable code with collection. Okay? Especially when you have a very large number of items in the array, it's rather difficult to actually come up with efficient multi-threading code that actually handles the data in parallel. So these are the issues with just using collections. So Java 8 provides streams to address these issues. So streams let you process data in a declarative fashion, meaning you specify what needs to be done rather than how it needs to be done. and it will result in simpler code. And in fact, it will result in more English-like description of the problem, which is expressive. Expressiveness is always good in computer programming. And streams support parallel processing very nicely. All you have to do is, in fact, creating parallel stream, and then it is the system that handles all this multi-threading and all those issues. So streams can leverage multi-core architectures without you having to write a single line of multi-threaded code. And stream is easier to optimize due to functional purity. So you're actually passing around function rather than a state. Okay, so it has a lot less chance of being in race condition. Okay, so example 1. So this is an example where you are using collection to create a sum. You could use a while loop, as you see on this slide, or you could use for loop. And again, here you specify how it needs to be done by using for loop and while loop. This loop, for loop and while loop, has nothing to do with business logic. It is basically structure that you have to actually depend on to compute the sum or average. So this is what I meant by how it needs to be done has to be coded by the developer. Now, this is example using streams. So here, in order to create a sum, you are going to create a stream object from the list object, and then you are going to filter. So here filter is receiving predicate, which is basically saying filter only the number that is greater than 10. And then you're going to use map to int, and it's basically generating integer stream, and then finally you say sum. So this is a lot more simpler to write code and easier to read. And it doesn't say anything about the structure that you have to provide in your previous slide. It doesn't involve any for loop, it doesn't involve any while loops. You just specify what needs to be done, and that results in simpler code. So the first part, this is the non-parallel operation, and if you want to create a parallel operation, only thing you have to do is basically creating parallel stream instead of the non-parallel stream, as you see on the top. So this is the non-parallel stream, and meaning sequential stream, and this one is creating parallel stream, and every other method, every other operation, stream operation, is the same. Okay, example number 2. So this is a bit more realistic example. So suppose you want to find all transactions. So we are talking about some kind of online transaction site. So we want to find all transactions of type grocery, and we want to return a list of transaction IDs sorted in descending order of transaction value. Now, if you want to come up with a logic using just collections in Java 7, this is probably what you have to do. So you're going to create the empty list object with transaction type, and then you're going to have a for loop. In this for loop, you are going to select only the transaction type, which is grocery type, okay? And you construct this temporary transaction list yourself. And then we are going to sort it. So we're going to sort based on transaction value. So we are going to use collections utility class and use a sort method, and we provide a temporary the list object we created in previous for operation. Then you provide comparator object, in which you are going to provide some compare logic. And then you are going to create another for loop in which you are going to just get the ID. So you need actually 2 for loops, and then we have a sort method here. So this is pretty complicated. Now let's see what you can do with Java 8 using streams. So here, again, this is the non-parallel operation, and on the bottom we are using parallel stream. Okay, and the rest of the logic is pretty much the same. Okay, so we create the stream object from the list of transactions, and then we are going to use a filter. Filter will receive predicate, the lambda expression. In this case, we are filtering only the transaction type, which is grocery. Okay, so here we take the transaction object, and then we call the get type method of the transaction, and we just compare whether that transaction type is grocery or not. Okay, so basically we are selecting only the transactions whose transaction type is grocery. Then we use sorted method, sorted operation, in which we provide sorting logic. So here we are using comparing method of the comparator, the class, and then we provide, this is an example of method reference. Okay, so here basically you are getting the value of that transaction, and then we also call reversed, operation to reverse it, and then we are going to get ID of that transaction. Again, this transaction : get ID is an example of method reference, just getting the ID of that transaction, and then you are going to call collect method to create a list object. So this is a lot simpler than what you see here. Okay, so you can see obvious the benefit of using streams. And of course, if you're using parallel stream, it will actually perform this operation in parallel. So if you happen to have 1 million transactions, performing in parallel, obviously it will result in the higher performance. Okay, so just to compare collection against streams. Collections are about data. It is the storage for maintaining and storing data, while streams are about computations. Streams are basically a set of operations that you can use to perform computations. Okay, computation operations include, for example, filter, or map and things like that. Using collection interface requires iteration to be done by the developer, meaning you have to be responsible for using for loop or while loop. And this is called the external iteration because you have to provide this iteration yourself. In contrast, the streams provide the iteration, stream handles this iteration for you. It handles all the storing of resulting temporary data somewhere, and basically all you have to be responsible is basically to call these operations. So this is called the internal iteration because iteration is being performed by the streams framework or streams library internally. Okay, so let's do exercise 1. So let's take a look at the lab documentation. Okay. All right, so here we are going to take a look at exercise 1, exercise external internal operations. So we're going to actually run 3 sample applications: streamed, fluent, compute sum. We are creating a sum, and we're going to take a look at the example of not using stream, and here you could use either for loop or while loop, and then we're going to use the stream operation. Okay, all right, so I'm going to actually just use the code. I assume most of you are familiar with JPassion.com. So basically, you have to we have to go to JPassion.com and log in. We are paying membership, and here you click Java 8 Lambda Programming, and the one that we are working on is let me just log in again, and you are going to download this lab. Okay, and you unzip the lab, and there is the sample application directory. So you're gonna actually import and existing. These are all Maven projects, so you're gonna actually expand Maven, select the existing Maven project, and click next, and you are going to select samples Maven project. So in my case, it is under labs, and then Java 8 Lambda streams, and there is a samples Maven directory, and this is you click it and you should be able to import it. Since I have imported them already, they are grayed out. Okay, so the one that we are going to take a look at is so this Fluent. So we're going to try the compute sum first. Okay, so if you take a look at this code, okay, so this is the case that we are using while loop, and here this is a case that we are using the stream. So here we create a stream object from the list of integer, and then we are going to filter, we are going to that the generating integer map, and then you call sum operation. Okay, and here this is the main method in which we create a list of integer, and then here we call the sum iterator method, which is not using stream, and then sum stream using stream. So let's actually run it. Alt Shift XJ and Alt Shift XJ. Why it doesn't actually let me just run this way. Run as and Java application, and the result is 2525, the same. So let's see whether we let's actually add another number, 6. Okay, and let's run it again, and it should, oh, I didn't save it, I guess. Okay, and let's run it again, and oh, why it doesn't actually it should have array list. Yeah, let me actually run this guy. Yeah, it should actually have a different number, right? Yeah, so let me just run it again. Run as Java application. Oh, this is interesting about the 66. Save the change. Oh, I see. So yeah, we have a filter operation, right? So that's the reason it's actually taking only the number that is less than 10. Okay, no wonder. Okay, so if I do the run as and Java application, then you should have a different number. Okay, yeah. All right, so for your exercise, create a stream-based method in which you filter only the number less than 9. Okay, so basically you are going to just change this predicate value. Okay. Alright, so I'm going to give you 2 minutes to finish this exercise. Let's move on to the next 2 exercises. One is employee salary, and then we're going to take a look at the transaction ID. So employee salary, so we have employee domain class, which just has the name, ID, salary, and country. Then in our main method, okay, what we want to do is we like to find all employees whose salary is less than $40,000 and who are located in USA, and then we like to raise their salary by 10%. Okay? So we're going to actually write code both using old way, meaning external iteration, and internal iteration, meaning stream. So you're going to actually write 2 code. One is using non-stream operation, and the other one is using stream operation. Okay, so again, this is the for loop. So we are going to go through this for loop of list of array, list of employee type, and then we compare. We actually selecting only the employee whose salary is less than $40,000, and also whose the country is on USA. I should actually use this one equals, because this is the string, right? Yeah, so I mean this is probably okay in terms of logic wise, but I should actually use something like equals. No, equals. And one more. Okay, so that's probably better code, but equals, I mean the equal sign still probably work. So we select only the employees whose salary is less than 40,000, and then whose country is USA, and then we are going to compute 10% more, and then we call the set salary to set them up. Okay, and we just display the employees. Okay. And now we're gonna actually create another one. The reason is because if you're not creating a new one, it's gonna actually use the changed list. Okay, so we want to actually start from a brand new list of employees, and this is actually using stream. So we create a stream object, then we're gonna use a filter. So the filter, you provide the predicate. Okay, so predicate in this case is the salary is greater than, I'm sorry, less than 40,000, and the country is USA. Okay, again, this one should be equals rather than equal sign if possible. And then we are using for each method, and for each method is one of the operation in which you can specify the function. So here, when the employee object is received, we like to actually call get salary and apply the 10% increase, and then call the set salary method to change the value of E, and then we display. Okay? So here, if I run the code, I'll do Shift XJ, and it actually has the same result. Okay. Alright, so for your exercise, create a stream from the list and filter only the people whose length of whose name is 4 characters. Okay, so create the list of people with names, and then we'd like to select people whose name length is 4 characters and whose salary is less than 50,000, and then we want to raise their salary by 100%. Okay. All right, yeah, so we already have people, so you don't have to create a list object, so you can just use this guy, right? Okay, so that is an exercise for this guy, and let me actually talk about the next exercise as well. That's a transaction ID example that we talked about in the slide. So here we have transaction, yeah, basically has an ID, transaction type, and transaction value. And the transaction type is enum, grocery, desk, or chair. And then we have a main method here. Okay, here this is again using so it's actually calling grocery transaction that is not using stream, and this is the one that is using stream, and this is the list of transactions. This is the test data. Okay. Now this is the example that we are not using stream. So as we have seen in the slide, we are doing for loop to create the temporary grocery transactions, and then we are performing a sort using sort method of the collection utility class, and then we create another list object which just take the transaction ID. Okay, now that is what you have to do using non-stream code, and this is what you do with the stream code. Here we're going to use the parallel stream. Okay, and then we're going to use a filter. So here we are going to just filter out only the transactions whose transaction type is grocery, and then we're going to use the sorted method. So here we provide the comparators comparing the method, and here you just provide the transaction. Okay, this is the same thing as, and we haven't learned the concept of method reference yet. This is again the Lambda expression where you are actually taking you are basically calling get value method from the transaction, and then you call the reversed, and then you are going to perform mapping. So basically you are trying to get the ID of the transaction, and then finally you are going to actually create the collection object. So since we haven't learned the Lambda expression, this is the same thing as this. So it's like T, this is a Lambda expression, and then T is basically getting it should be get it should be, let me actually see, get value. Okay, so I'm gonna actually find out the Lambda expression of this one while you guys are working on it. So I'm gonna actually let you guys do these 2 exercises, the employee salary and transaction ID, and I'll give you about 15 minutes to do that exercise. Okay, so for that method references, I should be able to actually change into Lambda expression like this. Yeah, so somehow Lambda expression doesn't actually take the, doesn't understand the, it is in fact the transaction type, and it doesn't actually does code completion. I think that's one of the Eclipse problem. But anyway, so I have to actually specify transaction type as a type of argument, and I can call get value. Okay, so as we're gonna actually see later on, you know, this could be actually extracted into method reference like the transaction : get value. Okay, and we can actually see that in method reference the presentation later on. Okay. Let's talk about the intermediate and terminal stream operations. So stream operations are you can think of them as the stream-based operations. The processing is actually considered as a pipe of stream operations. So you start with a source, and then we have a set of intermediate operations, and then we are going to have a single terminal operations. So pipe is made of multiple intermediate operations and one single terminal operations at the end. Examples of intermediate operations are something we have seen, for example, filter, map, and sorted. And terminal operations, examples of terminal operations include count and sum, reduce, for each, and find first. We're going to take a look at each of these operations in a bit more detail in the following slide. So you can think of working with streams, basically creating a pipeline, starting with a data source. Data source again could be a collection object. And then you are going to have a chain of intermediate operations which form a stream of pipeline. So if you see an example of this guy, we create a stream object from a list object. This is the source, right? And then this is creating a stream object. And then these are intermediate operations, a filter, sorted, map. And then finally we have a collect operation, which is the final terminal operation. Okay, so this terminal operation basically represents the end of the pipeline, and it actually triggers the execution of the stream pipeline and produces the result. Okay, so as we are going to see in the following slide, until terminal operation is executed, those intermediate operations do not get executed. So terminal operation is the one that actually triggers the whole stream processing. And we'll talk about that in a bit more detail later on. So these are those are type of the operations based on intermediate and the terminal aspect of it. And then in terms of the actual the functionality of those operations, it could be filtering operations. So filter, you receive the predicate, or distinct. This is like SQL distinct. You are going to select the distinct values. And limit, you are going to limit number of items that get generated. And skip, you are going to skip some number of items. Okay, so these are filtering operations. And then we have a finding and matching operations: any match, all match, and none match. And then mapping operation. Mapping is basically receive an item, then you're going to actually convert it to something. So that is mapping operation. And then we also have a reduce operation. So this is like a map reduce in Hadoop. Okay, so we're going to take a look at each of these in a bit more detail in the following slide and lab exercises. Okay. So intermediate operations are basically stream operations that produce always another stream. Okay, and it's always lazy. We mentioned the concept of lazy a bit before, but basically lazy means actual work is always triggered by the terminal operation, meaning the set of intermediate operations, in this case these intermediate operations, do not get executed until the terminal operations gets executed. So terminal operation is the one that trigger the whole processing of the stream. Okay, and this is called the lazy because until terminal operations gets executed, none of these intermediate operations are going to be executed. And there is a reason for that, and we'll talk about that later on. Okay. There are two types of intermediate operations. One is stateless operation, and the other one is stateful operations. Stateless operations do not require information on other items, while stateful operations require information on other items. So examples of stateless operations include filter or map, because these operations do not depend upon the state of other items. However, examples of stateful operations such as distinct, sorted, limit, and peak, it depends on the state of the other items, right? For example, a distinct operation has to know that a particular item is in fact distinct compared to other items in the list, in the stream. And sorted, again, it should know the order of the item compared to others and things like that. Okay, so let's take a look at the exercise 2. So we are going to do intermediate operations. So if you take a look at the lab exercises here, let's go to exercise 2, intermediate operations. We're going to try filter, and we're going to try map, and we are going to try the sorted, distinct, and limit. Okay. And these are all examples of intermediate operations. Okay. All right. So let's actually see. Let's try filter first. We have seen examples of filter already. Okay. So main.java here. Here we have a list of integers, and then we create a stream from the list of the integer object. And then we are going to just filter. We're going to actually get numbers that are just greater than 5. Okay, and then from the stream object, we are going to call for each. So this for each is basically the terminal operations in which you are going to display the value of it. Okay. All right. So for your exercise, I want you to create a list of names with Peter, Tom, Paul, and Sang, and filter out names that start with P and display them. Okay. All right. So I'm going to actually explain all these exercises, and I'm going to give you guys the time to do the lab exercise. Next one is map. Again, we have seen examples of map. Okay. So here here we have a list of numbers, and we perform filter, and then we have a map. Okay. Again, this is actually capturing set of intermediate operations, and then we are going to call for each terminal operations. So at this point, when the for each is being invoked on this stream object, it will actually trigger the whole stream processing. So here we are just displaying the number that is greater than 5, and then we are just performing. We are going to actually add 100 for each of this number. So it should be let's actually run the code. So it's going to be 106, 107, 108, right? Because it will take these numbers, and then we'll just add 100. Okay. And this one is again mapping operation. So here we are just mapping to uppercase. Okay. So here we map a string to uppercase, and then we are again performing the display the value. Again, this is an example of method reference, and this is again the same thing of you get the string object. So you get the string object, and then basically you are going to say string and and uppercase to uppercase, like this. It's the same thing. Okay, so when you run the code, it will actually perform changing uppercase, and of course if you change to lowercase, and then it will actually convert to the lower values. Okay. So the mapping here, the filter is actually for predicate, and mapping is to actually convert into something. Okay. If you decide to actually, if you want to add lowercase value to uppercase value, then you might want to actually do S to uppercase. Okay, and let's see what happens. And then it will have apple lowercase uppercase, orange lowercase uppercase, and lowercase and uppercase. Okay. All right, so for your exercise, I want you to create a list of apple, orange, and cherry, and create a string that contains a fragment of the names from the second character to fourth character. So I want you to extract this PPL from apple, and RAN from orange, and cherry from HER from the cherry. Okay, so that's the exercise. That's for map operation. And the last one is sorted and distinct and limit. So if you take a look at sorted and distinct limit, so here we are basically sorting it. Okay, and limit is, I like to have only 4 results. Okay, so here so let's run this guy. So we have 1, 3, 5, 6, right? So we want to distinct, sorted, and limit the numbers. Okay, so if I limit the number to 3, okay, then it should have just the 3 result, 1.3. Okay, and this is actually sorting. So this is the distinct. So we have actually 3. We have a multiple 3 and a multiple 5, right? So if you skip distinct, let's see what happens. Then, oops. We say just 3. Yeah, so if I say maybe 5, let's do that. And then, okay. Yeah, so then, the 3, 3, 3 are actually being not distincted. So if I just add it again and run it, then we have 5 of distinct values. Okay, so distinct is making sure the stream of data is in fact distinct, and then we sort it. And if you actually say here reverse I see. So reverse is not from here. Let's see. And then this is limit, and here we again distinct. This is unordered. So instead of sorted, we can actually say unordered, and here we get the 4 items, and distinct, sorted, and here we are going to have only 2 items. Okay. All right. So this one we don't really have any for your exercise. So I am going to let you guys do the exercise of filter and the map, and I'll give you about 10 minutes. So we just take a look at the intermediate operations. Now let's take a look at terminal operations. So the stream processing, as we talked about, is basically set of intermediate operations, and then at the end you have a single terminal operation. Okay, so basically terminal operation represent an end of the pipeline, and it produces a result from the pipeline, and the result could be a list, or it could be an integer, or it could even be a void. Okay, and any non-stream type. So as we talked about before, terminal operation is the one that triggers the whole the intermediate operations, and that is called lazy. Okay, so what that means is that those intermediate operations do not perform any processing until terminal operation is invoked on the stream pipeline. So intermediate operations are called lazy because they don't get processed until terminal operation is invoked. Okay, the reason why stream operation is designed in lazy fashion is because the intermediate operations can be merged and processed into a single pass, and that will actually result in efficient processing. What that means is that until this terminal operation is invoked, okay, instead of actually doing operation here and then here and then here, what it does is that these things could be actually optimized by stream framework. Okay. Another example is later on is like a limit. Limit is a great example. If you say limit here, like limit 2, something like this, that means, and then suppose if you got 1 million items, right? If you say 2, the only thing you care is just the 2 transactions, right? In that case, there is no reason to execute its intermediate operations for those 1 million items, right? 1 million transactions. Okay? So the idea is that until this terminal operation gets executed, which is always guaranteed to be the last one, we do not want to actually process the intermediate streams, because we like to actually take a look at all these intermediate operations, and then we'll figure out what is the most optimized way of actually performing this stream processing. Okay, so that is what is called the lazy operation. Again, this could be actually compared to for loop. If you remember this transaction example, suppose if you have 1 million items, here you are going to perform this for loop for 1 million items, and you're going to actually perform sorting for 1 million items, and then you're going to actually do this for 1 million items, and later on you just want the 2 as a result, a number of results, right? So you are basically performing all these things in vain. I mean, you are basically wasted a lot of cycles. Okay, but if you're using streams, basically it will be optimized. It will know the final result could be just is going to be just 2 items. So I don't have to go through all those million items for filtering and sorting and mapping. Okay, so those kind of optimization could be performed by stream library. Okay, because it's lazy. Okay, so these are examples of terminal operations. For each, we have seen that example already. Count and sum, find first, find any match, all match, non-match, and reduce. So let's take a look at each of these in a bit more detail. For each, it performs an action for each element of the stream. Okay? By the way, the behavior of the stream is non-deterministic. What that means is that it doesn't guarantee that it will handle the items in order. So suppose if you get the stream of 1, 2, 3, 4, 5, 6, and 7, and 8, and here what we do is we are going to filter only the number that is greater than 5, and then for each of the number that is greater than 5, we are going to perform this operation. So we're going to just print things out. Okay? But what I'm saying here with this bullet is that the order of the stream is not guaranteed. Okay, in general it will be in the order, but that's not guaranteed. So in this case it will be printing 6, 7, and 8. But what I'm saying is that it could be printed to 7, 6, 8 instead of 6, 7, 8, right? Because order is not guaranteed. So that is for each. And count and sum. Count returns the count of items or elements in the stream, and sum is sum of the elements. In this case, count is we like to filter only the number that is greater than 3. So we have 4, 5, 6, 7, and 5. So count will return 5. And here we are going to sum. In order to sum, you have to actually create the integer stream. So that's the reason we have to have map to int, and then we create the integer stream. So this will add 4 plus 5 plus 6, 7 plus and 8. That is sum, final operation or terminal operation. Find first and find any. So find first and find any returns optional. This is the newly introduced class in Java 8. optional describing the first element of the stream, or empty optional if the stream is empty. If it doesn't find the one that meets the requirement, then it will return, it will actually have an optional of empty. Find any is actually finding any, and find first is find the first one. Okay, all right. And the find any also behavior of this operation is not deterministic, meaning it will choose any instead of the first one in the stream. So in this example, suppose we have a names stream that contains 4 names, and we like to filter the name that start with a T. We're going to actually filter out only the names that start with a D, and among those we are going to actually get the first one. And if there is in fact there is one that starts with a D, then this optional has a method called isPresent, and that should return true. Then we should be able to call get method of that optional, and then we can print it out. Okay, so find first is finding the first one, and find any is finding any that meets the requirement, this filter requirement. Now, any match, all match, and non-match. Any match, take the predicate, just like a filter. It returns whether any element in the stream matches the provided predicate. All match, meaning all elements match the provided predicate, and non-match, and none of the elements match the predicate. So let's say an example in this slide. So we have a list of numbers. 1, 2, 3, 4, 5, 6, 7, 8. Oh, we don't have 5 here. So we have a 1, 2, 3, 4, and then skip 5, and then 6, 7, 8. So here, if we use, so we have, we create the stream object from numbers array. Then if you use any match, and the predicate is I equal to 5. Okay, so there is no item that is 5, so it should return false. Okay. And all match, the predicate says that number has to be less than 10, and all numbers are in fact less than 10, so it should return true. The last one is non-match, meaning none of the numbers matches this predicate. So none of these numbers is 10, so it should return true as well. Okay. So any match, all match, and non-match returns Boolean. Okay, reduce. So it performs a reduction on the elements of the stream using an associative accumulation function, and returns optional describing reduced value if any. So in this case, we have a number 1, 2, 3, 4, 5. Okay, and we have a reduce function which taking the 2 items I and J, and then it is going to multiply the number, and then it will actually repeat the process. What it does is this: it will take the 1 and 2, and then it will multiply. So that is 2, right? It will return 2. Then 2 is going to be used as the I, and then 3 is going to be used as a J. So 2 times 3 is going to return 6, right? Then 6 will be used as an I, and the next item, in this case 4, 6 times 4 is 24, right? And then that is 24 is used as an I, as a first argument, and the last item 5 is going to be used as a J. So 24 times 5 is going to be 120, so it will return 120. So reduce is basically taking these 2 items, and then so these 2 items, and then perform the operation, and then it will actually take the next item as the next argument. So basically it actually reduces the elements in the stream. Okay, so let's take a look at exercise 3. So exercise 3, we have a bunch of terminal operations. So let's actually go over from the beginning here. So counter and sum. So here we have a number of this. Yeah, so this is the same example. Okay, so if I run the code, and so count number that is greater than 3 is 5, and sum of the numbers is 30. Okay, so that makes sense. Okay, so if so we just filter out that is in fact 4, 5, 6, 7, 8. So it should actually return 5. Did it? Yeah, so it returns a number of greater than 3 is 5. Okay, and this is this one. We want to actually filter out the numbers that is greater than 3, and then we are going to just create the input stream, and then we are going to have a sum. Okay. All right, for your exercise, create a list of names: Sang, John, Paul, and Leo, and filter names length of which are greater than 3. So you can actually select here Sang and Paul maybe, and then use map operator to map the name to the length of the name, and then I want you to use count and sum, okay, to get the count and also sum. So that's its count and sum, and find first. So here we have a list of streams. So this is another way that you can create a stream. So stream.of, and you provide list of items. Okay. So here we are going to get we're going to actually select only the names that start with a D. So that should be David and Dadu. And find first. It should actually return David. Okay. And we are going to start it again with this value, and then here we are going to select find any, so it should return either David or Dadu, right? Okay. And here we are actually using if present right away after find any, and then we are going to print it out. Okay, so this is another lambda expression. So if present will take a lambda expression in which it will actually get the result of this and then just print things out. Okay. For your own exercise, from the names stream, filter the names whose length is greater than 3, and then use find first and find any. And also, given the list of numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, find the first number who's greater than 3, an even number. And so we have two conditions. It has to be greater than 3, and then it has to be an even number, right? And then double it. And then so this one, since we have learned the method reference, you don't have to do this exercise. Okay. That is find first, and find, so that's the solution is actually from the solutions directory. And then for each, so this is for each. So we are basically select the numbers greater than 5, so 6 and 7, and we are just print things out. Okay. So if I do run it, and it will just display 6, 7, and 8. Okay, so for your exercise, create the list of names, filter names whose length is greater than 3, and then use for each to display them. Okay, pretty straightforward. And the match. So here we are using any match, and any match, all match, and none match. So this is the same example that we have seen in the slide. For your exercise, create a names list with these 5 names, and check if there is a name that starts with S, capital S, and small a. Check if length of every name is greater than 3. Check if there is a name whose length is 5. Okay. All right. So that is a match operation. Reduce. So let's take a look at the reduce. So this is going to be an interesting exercise. So we have a number array, and we are going to reduce this guy. So this is something that we have seen in the slide. So if we are basically multiply, it should return 24, right? And if we are just adding it, it should return 10, right? Okay. And then here, if we perform concatenation, so it will actually take apple and orange, it will concatenate it, so that should be apple and orange, and then that will be used as an I, and then it will take cherry as a J, and it will all concatenate. So it will return apple, orange, and cherry. So let's actually run that guy like this. So it should actually return apple, orange, and cherry. Okay. Now, for your exercise, I want you to create a names list with Sang, John, David, and Mary, and Dadu. Perform reduce operation so that string that is made of the first character of each name is concatenated. Basically, the result I want to actually get from this is S, J, D, M, D. So this is what I want, right? So I want you to try to solve this one and see whether you can come up with a solution. Okay. All right, so let me just pause. Next topic is laziness. We talked a little bit on laziness, right? Okay, so as we talked about, intermediate operator runs only when terminal operator asks. So in this example, we have a stream object, and then we just happen to have only intermediary object, intermediary operation. We perform map and we perform filter. So inside the filter, we are basically having some system of println statement. Okay. When we run this guy, it will not print these things because there is no terminal operation to trigger the execution of these intermediary operations. So you are not going to see any print. Okay. So this is why laziness is in fact useful. So I talked about this one before as well. So suppose if we have a list of numbers here and we're going to perform filter operation, here we're going to filter out only the number that is actually even, then we're going to actually multiply by itself. So we're going to actually create a square value, and then we say limit 2. So what we want to observe is that as soon as the system finds that there is a 2 the items that meets the requirement of this, it will stop the operation. Okay, so in the example below, limit 2 uses the shortcut circuiting. We need to process only the part of the stream, not all of it, to return a result similar to evaluating to large Boolean expression. So basically what we are talking about is that suppose we got million numbers here, and we say limit 2. In that case, the system, the stream will actually take a look at only the things that are needed to satisfy this number of items returned in this case 2. Okay, so that is the reason why laziness is in fact useful, because laziness will take a look at all these intermediate operations and then will actually perform some kind of optimization. Okay, in this case, it will figure out that it needs to have just 2 as a result. Okay, so let's take a look at exercise 2, exercise 4. So exercise 4 is basically, seeing, in this case, this is a case that we are actually seeing only the 2 items. So let's actually run this code. And so you can see, yeah, we have a print statement and both a filter and map. And we just actually see the result here, and you can see it will actually filter and map only the items that meet the 2. So you are gonna actually see it's gonna actually filter 4, and then it's gonna actually perform 2 mappings, okay, because that's the only thing that is needed here. If I say 3, right, so let's actually run 3, then it will actually perform more. And so instead of 6 items filtered, as 4 items filtered, it will actually perform 6 items to be filtered. In terms of mapping, it will have just 3 mapping. Okay. So for your exercise, increase the limit. Yeah. So that's basically that's what we just did. Laziness O2. So this is an exercise here. We're gonna actually see whether so here this is a case that we do not have terminal operations, a map and just a filter, and the filter has the print out println statement, right? So when we run this guy, you're not going to actually see any println statement. Now at the end here we have a collect. This is the terminal operation. So here we're going to actually see the println statement. Okay, so let's run this guy. So the first one, there is no println statement. However, on the second one, because we have terminal operation, it actually shows the println statement is being used to print things out. Okay. All right. So this is actually a little bit too easy for you. So I'm gonna let you guys do this exercise. I'll give you just 2 minutes. Last topic is parallelism. So parallelism introduced in Java 8 streams is actually extremely useful. And before Java 8 parallel stream, developers had to use all kinds of very complex APIs, such as a join and fork, and it's very complex, and it's not even guaranteed to work as as expected in some cases. If you do not actually partition things incorrectly, then it's not going to work as expected, right? So and also another issue is the collections are not thread safe. I mean, there are actually thread safe collections, but they might actually result in better performance. These are the issues. So basically, Java 8 introduced parallel stream, and you can run stream either in the form of serial stream or parallel stream. The only thing you have to do is basically using parallel stream method to create a parallel stream. So in fact, there are two different ways. You can use parallel stream utility method of collection. I think, I'm not sure it's a collections or not. Okay, or you basically create the parallel stream. Oh, I see. Yeah, so it's a collection type and parallel stream, and that's what we do. Here we have a list of, the something, and then we're gonna call parallel stream. Okay. Or if you have a singular, if you have a serial stream object, then you can just call parallel method, and that will actually convert it into the parallel stream from a singular, the serial stream. Okay, so only thing you have to do is just creating a parallel stream, and everything else will be taken care of. Okay. All right. So exercise 5, we are going to actually try to run some operations in serial and parallel fashion, and see the performance difference. So here, let's take a look at this code. So here, what we are going to do is we create a test data. So we're going to create the test data of max of, we're going to create the test data of 5 million items. And then we actually measure the performance. Okay, so basically this is using sequential filtering. So what we do is we are going to, we're going to perform some filter operation, whether the number is greater than threshold or not, and then map int, and then we actually create a sum. Okay, and this is a parallel. So here we are using serial stream and parallel stream, and we just kind of measure the duration. Okay, so let's actually run this code. Okay, so here the sequential, it takes the 95 millisecond, and parallel stream, it takes the 80 milliseconds. So it makes a little bit of difference, but usually I get like a twice better performance. So let's actually run this guy one more time. Oops. Yeah, 8980. Okay, so what I want to do is, how about we are going to try threshold, and we are going to perform map operation dot map, and I times I. So we're going to actually create a square. So let's copy this guy, and also filter. Okay, so let's run this, see whether we have a bit more. Okay, so this time sequential is taking 1638, and parallel is taking 92. I mean, it's a huge difference. Okay, in our previous exercise, we are not doing anything really significant. We just perform filter, right? But here we also actually perform map operations. So we are computing the square value of the number. So this one is huge difference. Okay. All right. So I'm gonna let you actually run this exercise, and get the sense of this parallel stream. Okay. And I think that